Hi guys! In this lesson we are going to be reviewing how to work with numbers that are written as powers and numbers that involve the use of exponents. So if you have your textbook handy, it's lesson 9-1 on page 471. Of course, I'm suggesting that you take notes, and certainly going to want to have a calculator handy for this lesson. The first definition you see here is what is an exponent. Now, we're in 8th grade, right? This is not our first go around with what exponents are, but just to be clear, an exponent tells how many of the base number need to be multiplied together, or how many of the big number do you multiply by itself, or how many times should you write it and then put multiplication signs in between it. I mean, to put it in the most basic of terms, right? So if you see here, the example that I have is 5 to the third power. So I'm looking right here. The exponent would be the 3. That is the exponent. So this is 5 to the third power, also known as 5 cubed, by the way. And so the exponent of 3 tells us that we're going to take 3 of the base number, which is 5, right? Base number is the big number, and we're going to multiply them together. Now we're not adding. This is not 5 plus 5 plus 5 is 15. And this is not 5 times 3 is 15. No. This is take 3 5s, 1, 2, 3, and multiply them together. And then actually the answer, if you were to do the math, would be 125. The next definition is what is the base? Well, that is the number that gets multiplied by itself. So when a number is written as a power, the base number is the big number, and the exponent is the little tiny number that's raised up and to the right. So in this example, again, 5 is the base number, and that's the number that we multiplied by itself 3 times according to the exponent. So again, for recap, when you write a number using an exponent, that's called expressing it as a power. So that's the next definition you see. When a number is expressed using an exponent, we call that it is written as a power. So here down in red, kind of referring back to our 5 to the third power, 125 as a power of 5 means how can you get to 125 as an answer if your base number is 5? So how many 5s being multiplied together would it take to get up to 125? And the answer is 3. 5 to the third power is 125. Again, a lot of kids get caught up and they think 5 times 3. And it's not 5 times 3. It's 5 times 5 times 5. So 5 with an exponent of 3 is called 5 to the third power. But you know what? I really feel like that should be a review at this point. I know they cover exponents in 7th grade, and I'm pretty sure even in 6th grade, possibly even 5th grade nowadays. Hard telling. The last thing on this slide down here at the bottom is actually pretty important, and it's going to sneak up on you in this lesson, and hopefully you remember this. Anything that is raised to the power of 0 is 1. Now that seems weird. That anything with an exponent of 0, when you do the answer, or when you calculate the answer, is 1. So the examples here are 5 to the 0 power is 1. Anything to the 0 power is 1. Even a variable like y. Anything to the 0 power is going to have an answer of 1. So if that sneaks up on you in this lesson, you've been warned. Let's see some examples of what we're going to be doing in class when we work on this lesson and these examples, this assignment together. Directions say write each expression using exponents. So we're not going to be evaluating these. We're not going to be solving them all the way to get final answers. I don't want to know that the answer is 100 and whatever. We're just going to rewrite these expressions as a base number with an exponent. So if I'm looking at this first one, obviously the base number is 4. How many are there? 1, 2, 3, 4, 5. There are 5 of them getting multiplied together, so the exponent is a 5. This is 4 to the 5th power. And I don't want to know what the final answer is. They didn't ask for that. The next one, what is the base number? It's negative 8. Notice that it's in parentheses. It's in parentheses for a reason. if they show it in parentheses, you too need to write the base number in parentheses. It all has to do with that negative attached to the 8. How many are there? 1, 2, 3. So this is to the third power. Now, on a little side note here, if you did not have it in parentheses, that does, in fact, kind of change what the problem is telling you to do. We'll get into that a little bit more when we're in class together. But for now, just realize that if they show parentheses, you need to show parentheses around the base number, okay? You leave those parentheses off, especially if it's a negative, and you're very likely going to end up with an incorrect solution. What's the base number on this next guy? 6. How many are there? 4. So 6 to the fourth power. Moving on down, that negative 2 is in parentheses, and there are, again, 4 of them. So it's negative 2 in parentheses to the fourth power, which is different than this answer. That would end up with different solutions. So again, watch out for those parentheses. Interesting. Look at this guy. This guy's a fraction. Yes, it's in parentheses. I think it's a good idea to leave it in parentheses. 1/2. How many are there? 3 of them. So that means the whole thing has an exponent of 3, meaning the numerator would have an exponent of 3 and the denominator would have an exponent of 3. So 1/2 to the third power. That's how you write expressions using exponents. Ooh, what about these? This is interesting. Can you tell what the base is? It's the y. That's the base. How many are there? 1, 2, 3, 4, 5. So it's y to the fifth power. What's the base on this next one? In parentheses, right? It's k plus 2. How many are there? 3. Again, parentheses are there. You need to use them. If you don't use the parentheses, it would look like this. So the difference is, with parentheses, the exponent of 3 would be given to the k, right? Almost like the distributive property. It would go there, and it would go there. If you don't use the parentheses, it looks like the 3 is only attached to the 2. So that would be incorrect, right? All right. And we're not solving these yet. We're just rewriting them. The next one is interesting. I see something that I can actually solve here. Do you see this 2 times 3? Yeah, right? You know what that is. That's a 6. So if you see a part of the expression that you can solve, please do so. Now, what else do I have? I see that I have an f. How many are there? 3 of those. It gets an exponent of 3. And there's a g. So that's the answer. 6 f to the third power g. The g doesn't have the exponent of 3, right? Because there aren't 3 g's. There's only 1 g. Okay, we're almost done. Now here's where you're going to want to get your calculators fired up. This says evaluate. Evaluate means solve. We're going to be solving these. We're going to be substituting in values for the variables. We're going to be using order of operations, right? Please excuse my dear Aunt Sally. Remember that. And some of these involve some pretty tricky numbers, so make sure you got your calculator ready. Here we go. X squared plus y to the third power. What is x? X is 6. So I'm going to rewrite the expression, and instead of the x, I'm going to put a 6. It has an exponent of 2. Plus y. Y is negative 2. Why am I putting that in parentheses? Because it's a negative. And it gets an exponent of 3. All right. Next step down. Let's do the exponents. What is 6 to the second power? It is not 12. 6 times 6 is 36. Plus negative 2 to the third power. If you're using a calculator, you need to put the parentheses in. So on a calculator, I would type parenthesis, negative 2, parenthesis, and then you could do the exponent button and make sure you get a 3 in there. If you remember the exponent button, it's like the little caret button over here. Or you can just take negative 2 times negative 2 times negative 2. Anyway, you should end up with an answer, hopefully if you did it right, of negative 8. Now, what is 36 plus negative 8? Well, again, if you're not good at working with integers in your head, punch it in a calculator. As much as it hurts me to say that, unfortunately, some of us just need to do that. Okay, good. Let's try, I think we have 2 more. Here we go. Yep, these are the last 2. So, in parentheses, we have a plus b, whatever that is, and then that whole thing is being raised to the 3rd power. Let's substitute in our values. It says a is 5 plus b, which is negative 2. All of that to the 3rd power. So, inside parentheses, what is 5 plus negative 2? That's a 3. All raised to the 3rd power. 3 times 3 times 3 is not 9. It's 27. Okay? Last problem. 2 minus c to the 2nd power if c is 3/4. Oh boy, fun times. 2 minus 3/4 to the 2nd power. Why did I put 3/4 in parentheses? Because it's a fraction, and when a fraction has an exponent, it really should be in parentheses. So 3/4 times 3/4 on your calculator would give you 9/16. 2 minus 9/16 is 1 7/16. Final answer. We will review a couple of these ideas quickly in class before we work on the assignment together. And if you'd like to take a look at it ahead of time, this is the assignment. I will see you in class. Thanks for watching.